An isosceles triangle has a perimeter of 38 inches. What does perimeter mean? Asia? The distance around. If I add up all the sides of this triangle, I'm going to get a 38. The two shorter sides have integer lengths equal to n, and the third side is equal to n plus 8. So isosceles means two sides are the same length, and the third is a different length. So normally you'll see that with these little marks right here that mean those two are the same length. And we'll look at that more when we get to geometry. But these two sides are equal to n. And this third side is longer, the base, but it's n plus 8. And so what I know that means is if I add up n plus n plus n plus 8, that has to equal 38. The problem tells me that. So this is how I should set up that equation. N plus n plus n plus 8 equals 38. Everybody see where that came from? Can I combine like terms there? Yes, what am I going to get, James? Yes, 3n plus 8 equals 38. Now I have a two-step equation that I can solve. What's the first thing I can do? Marcus? Yes, subtract 8 from both sides, and I'm left with 3n equals 30. Because what I did was I took this 8 that's different from everything else, I took it off. And so now these n's, 3 of them equal 30. Now I'm going to divide by 3, divide by 3. Each n equals 10. Okay? Am I done with the problem? No, it says what are the lengths of each of the three sides. So I know that this side is 10. I know this side is 10, but is this side 10? No, it's 10 plus 8, and that equals 18. And then if I added those up, 18 plus 10 is 28, plus another 10 is 38. So now I need words. The lengths of the two shorter sides is 10 and 10. The length of the long side is, I ran out of room, 18. The lengths of the two shorter sides is 10 and 10, or the lengths are, I have bad grammar, the lengths are 10 and 10. The length of the long side is 18. We don't know units, right? I can't say inches or centimeters. All we know is a 10, and an 18. Oh, does it say inches? Oh, it does. Okay. Let's put our units in then. The lengths of the shorter sides are 10 inches and 10 inches. The length of the long side is 18 inches. Everybody okay with that? So I want you to glue this in your math journal on page 39. Add linear expressions. No, 38. Glue it in on page 38. Yeah, there's no room on 39. Glue it in right here on 38. Attach it right there. Let's move on to the notes for this page right here. If you're looking at the front of it, we're going to fold it in half like that. And you are going to just cut on this dotted line. So we just want individual flaps, but only cut to the center. Cut on the dotted lines. Oh, you can't rip those. No, you can't. You're not that good.
It is nice and neat. I'm pretty efficient.
10 seconds. All right, so we're going to take some notes about graphing inequalities. After we solve inequalities, these are some notes about graphing. So we're going to start up here with what it looks like when we graph an answer that is less than. Draw the less than sign on the front. You can use a highlighter, you can use your pencil, you can use whatever you want, but you need the less than sign right there. All right, so that sign means less than. So an example is if we were to graph B is less than 4. So let's use B is less than 4 for our example. So over here we have an open number line. We need to make sure that on our open number line, somewhere in the center is the number 4. Number 4. So going larger, you have 5, 6, 7. Smaller, you have 3, 2, 1. An open number line does not have to have every number on it, but it has to have the number. If we're saying B is any number less than 4, you have to have a 4 on there. And you want to have numbers greater than 4 and less than 4 on there. So if we got an answer that B is less than 4, it doesn't include 4. So you have to have an open dot. Do you remember this from last year? Okay, so open circle, because it does not include 4. B is any number less than 4. So open circle. Do you need me to zoom in a little bit? And then it's going to be all the other numbers less than 4. So if this is pointing in that direction, that's the way we want to graph. Don't graph above it. Let's see. Let me use a highlighter. We're going to go from here, and we're going to go in this direction. All the numbers in that direction. B can be any number less than 4. So B could be 3. It could be 2. It could be 0. It could be negative 20. Could be B4. If we're saying B is any number less than 4, does it include 4? No. Does it include 3.99999? Yes. Any number all the way up to, but not including 4. Does that make sense? So it also includes all those negative numbers that are down there to the left. All right. The next sign that we are going to use is less than or equal to. Make sure you get your equal to. Less than or equal to. So let's use E is less than or equal to 8. E is less than or equal to 8. So in our open number line in the center, put the number 8. To the right, the number's bigger, so 9, 10, 11. And to the left, smaller, 7, 6, 5. So E can be any number less than or equal to 8. So since it includes 8, we need a closed circle. Close it in. It could be exactly 8. But it could also be any other number less than 8. So use your highlighter and go in that direction. So E can be any number less than or equal to 8. So it could be negative 1,000. It could be negative 1. It could be negative 1/2. It could be 2, 3, 4, 5, 6, 7. But it could also be 8. Could it be 8.5? No, 8.5 is sitting over here between 8 and 9. So it can't be any bigger than 8.0. Does that make sense? Okay. All right. The next one that we are going to do is greater than. Greater than. You need a greater than sign. And the example we're going to use is A is greater than 5. So, could A actually be 5 if A is a number greater than 5? No, so it needs to have an open circle, right? Open circle because it can't include 5. It's all the numbers greater than 5. But we're going to go in the greater than direction. Make sure that you're graphing right on the number line. So, A can be any number greater than 5. So what could A be? What could A equal? Let's try that. What could A equal? 6, 9, 6, a million, a billion. Could it be 5.1? Yes, that's bigger than 5.0, right? Any number bigger than 5.0. So 5 in any decimal or fraction. Bigger. All right. Let's try the next one. It is greater than or equal to. So greater than or equal to looks like that. And the example, let's use C can be greater than or equal to -5. So on the center of your open number line, let's put -5. Is it going to be an open point or a closed point? Closed, because it could also equal -5. So a closed circle. And then which direction does my arrow need to go? To the right or the left? Right, we're going to point in the same direction. Any number greater than or equal to -5. Oh, we need to put some numbers on there. So these negatives are a little bit harder. What should be over here? -4, -3, -2. This way is a -6, -7, -8. I forgot to fill in my number line on the one previous. You can fill that in if you want. All right, questions so far? Okay, the last one that we're going to do is not equal to. Not equal to. So that looks like an equal sign, but with the not drawn through it. So we could say S is not equal to 3. S is not equal to 3. So if S is not equal to 3, what could S equal? Anything but 3, right? So in the middle, we're going to put a 3. 4, 5, 6, 2, 1, 0. So is it going to be an open circle or a closed circle? It can't include 3, so it's open circle. But it could be any number to the right or the left. It could be any of these numbers in this direction. And it could be any number in this direction. It just cannot include 3. It could be 2.999. It could be 3.01. It just cannot be 3.0. All right. So do we remember this review from last year? Yes. So when you go to graphing, you can look at it. All right. Put that to the side. We're going to do all the gluing at the same time in just a couple minutes. Let's look at the notes with the flip-flops. There's lots of notes for inequalities because there are lots of rules. So as we've been solving equations and two-step equations, do you remember if we had like 3 equals n, we said don't switch the sides because it's going to matter later? Well, it's in inequality that order matters. In inequality, the order matters. Mark order matters. Your order always has to be the variable. Your inequality symbol comes next. And last is going to be your constant. So, for example, you have to have x, your variable, and then, for example, greater than or equal to, and your constant might be 7. Whenever you solve an inequality at the end, you always have to make sure that your answer is variable, inequality symbol, and constant. So, what we need to think about is if you have to flip-flop the inequality, you must also flip-flop the inequality symbol. So, let's look. If our answer is 11 is greater than b, if our answer looks like this, 11 is greater than b, you cannot have it like that. That's constant inequality symbol b. So if you have to flip this around to where the b comes first, you also have to flip this sign. So if the b needs to come first, do you see how the inequality symbol, the point's pointing at the b? When you move it and flip it this way, it still has to point to the b. This matters. You have to pay close attention to it. All right, any questions about what this says? No? Okay, put it to the side. We need this one right here that says the golden rule of inequalities. When you multiply or divide both sides of an inequality by a negative number, you must flip the inequality symbol. So here's the steps. Get the variable by itself on one side of the inequality symbol. Check the order. Make sure it says variable, symbol, constant. You need to then decide if it's an open circle or a closed circle. Then you have to circle the number on the number line, and then you have to shade in the correct direction. These are your steps when you're solving. If you forget what to do, this is where you want to go back to, these steps. So let's highlight that right there, steps. So when are we going to have an open circle? We're going to have an open circle if we have a less than, a greater than, or a not equal to. When we're graphing, we'll have an open point or an open circle if it's less than, greater than, or not equal to. When are we going to have a closed circle? A less than equal to, a greater than equal to, or just an equal to. So we're going to solve this right here. It's a little bit more difficult than the ones we'll be doing, but we'll solve it. 5 minus 3x is less than or equal to 13 plus x. All right, so the first thing that we need to do is we're going to move the constants. Let's get rid of this right here. Negative 5 minus 5. Let's move that 5. We'll get rid of it over here. We're left with negative 3x will be less than or equal to 8 plus x. Now what do you think we want to do? We have x's on both sides. Let's leave this constant here and let's get rid of this positive x. What's the opposite of a positive x? So let's subtract an x from here and subtract an x over here. If I have 3 negative x's and another negative x, negative 4x. All right, now remember the golden rule. If I have to multiply or divide by a negative, I'm going to have to flip my sign. So divide by negative 4, divide by negative 4, and you're going to be left with x is greater than or equal to negative 2. So remember to flip the sign. And why did we flip the sign? Anybody remember? Because we divided by a negative, we had to flip the sign. Now we can graph it. X could be any number that is greater than or equal to negative 2. So what do I want to put it down here on my number line? A negative 2. Open circle or closed circle? Closed circle. And it could be any number in that direction. Any questions about those examples? All right, let's try this last page with some examples on them. And then we'll get it all put in our journal. Inequality notes. An equation is a statement that says two quantities are equal. So we've been doing equations. Now we're going to work on inequalities. An inequality is a statement that says two quantities are not equal. The chart below shows some symbols and phrases that indicate inequalities. So if we see less than, it's this sign, fewer than or below. If, as you're reading words and trying to translate it, if you see those, it's that symbol. Greater than, more than, or above is this symbol. Less than or equal to, these are the difficult ones. At most and no more than. If you see those, that's a less than or equal to. Greater than or equal to, that one's pretty easy, but if you see the word at least or no less than, that means greater than or equal to. These are the hard ones. As we're going through warm-ups and doing word problems, you may need to reflect back to this page. So let's do these examples. No more than 200 people can be seated in the restaurant means the number of people in the restaurant is, so if it says no more than, then it needs to be less than or equal to. That sign goes in there, less than or equal to. 2, the waiting time for a table is at least 20 minutes. That means it could take 20 minutes or it could take more than 20 minutes, right? So, greater than or equal to. The price of all special dinner entrees is below $10. Does that mean it can include $10? No, it's just less than. Less than. The Yoshida family spent more than $40 for dinner. Could they have spent exactly 40? No, it says they spent more than 40. That has to be greater than. So sometimes those words to numbers can be a little bit difficult. All right, let's solve this inequality. This is just like if this was an equal sign. So h minus 16 is less than or equal to negative 24. So we're going to add 16 to both sides. H less than or equal to negative 24 plus 16. Anybody know that math? Negative 24 plus 16. Marcus? Negative 8. So h could be any number less than or equal to negative 8. So when you see this, now you have to draw an open number line. Looks just like that. Draw an open number line. What number needs to be in the middle? Negative 8. This way they get bigger. Negative 7, negative 6, negative 5. If you're having trouble, use the number line at the front of the room. Is that going to be an open dot or a closed dot? Look at this sign. Closed. And it needs to go in this direction. H has to be any number less than or equal to negative 8. So I'm just going to use a highlighter so that you can make sure you see it a little better. Goes in that direction. All right, any questions on that one? Okay, let's try the next one. Y plus 6 is greater than or equal to negative 13. What's the first thing I want to do on this one? Anybody know? What is it? Subtract 6 from both sides. Subtract 6, subtract 6. Y is greater than or equal to negative 19. Very good. Now we need to graph it. So, open number line. What number in the middle? Negative 19. Open circle or closed circle? It's greater than or equal to. So it can include 19, so it's closed. Closed circle. And we need to go in that direction. Any number greater than or equal to. So y could be a negative 18, it could be a negative 17, a negative 16, it could be a positive 20, right? Anything in that direction on the number line. All right, you ready for this last one? How does this one look different than these two?
Well, they don't have
The variable is on the wrong side. And remember, order matters. So we're going to have to solve it, and then we're going to have to do some flipping, right? Okay. Negative 4 is greater than h minus 2. So I've got to get rid of this subtract 2. What's the opposite of subtract 2? So we're going to add 2 to both sides. Negative 2 is greater than h. So now we've got to flip it. And remember, if we're going to flip the h around, this point has still got to point to the h. So it's going to be h is less than negative 2. Make sure you flip it around to where if this point was pointing at the h, now when I flip it, it's still pointing at the h. Now can we graph that? Yes. Open number line. What's going to be in the center? Negative 2. Open point or closed point? Can it include negative 2? No, so it has to be an open point. And it's going to be all the numbers in that direction, less than. So it could be negative 3, it could be negative 4, it could be negative 10, negative 1 million, any number in that direction. But make sure you know that point is an open point. So what are some of the important things we need to remember as we're doing this? We solve them just like we solve an equation, but we need to know that order matters. It has to be a variable, inequality sign constant. And we need to remember that if we multiply or divide by a negative number, we have to flip-flop the sign. There's lots of notes, lots of details we have to remember about this section. All right, so let's look at our journal and see where we are going to put these notes. All right, so looks like the next available page is 52. Is that correct? So on 52 and 53. Let's see. Let's put this one on 52. This one on 53. right, then turn the page. 54 and 55. Next two. Did you find more? Okay, so 52, 53, 54, and 55. So the first two look like that. Everybody okay with the first two? And then the next two look like that. So our table of content is going to say 52 to 54 or 55 inequalities. 52 to 55 will be inequalities. And we will be spending the next 3 days working on inequalities. So we're going to get lots of practice. So 52 to 55 inequalities. All right, and look up here and I'll show you what you're going to work on. You can work with the people around you at your desk. You're going to pick up one of these blue sheets and you'll need these 8 graphs and these 8 algebra statements. And so what you're going to do is you're going to work with a partner. And if the words say x is greater than -5, look on here and find where you see the statement x is greater than -5, and that's this one right here. You're going to cut it out and glue it here. And then you're going to find the matching graph. And then you're going to cut it out and you're going to glue it there. That's all you're going to do is look for the matching graph statements and the algebra. That's easy enough. Okay, make sure you put your name at the top. You've got about 15 minutes to get this done, and we'll get these passed out to you. Questions?